Okay, just a quick note. The quiz, I believe it was quiz 4 that was due last Thursday. I did go back in and reopen that and set it so it should be open until this Friday. For those of you that got cut off because of the time zone issue with it. So it should now be open until midnight this Friday night. So you can take it now, or you can come back after the test on Thursday and retake it then if you need to. But that quiz is open, quiz 4 that was due from last Thursday. So you can go in if you got cut off or if you didn't get time for your second attempt, you can go back in and redo that. Also, there will be a quiz today after class. A quiz that'll be due at 11:59 tonight. I'll talk about, hopefully I'll mention that again at the end of class. And there is a new homework that is due for Thursday before you take the test. And then there is another quiz that is Thursday afternoon. That one is optional. So I won't make you do a test and a quiz on the same day, but if you do that one, it is worth extra credit. What I usually do is if you do those quizzes, I will use whatever score you get on that to bump off your lowest other quiz score. So it can't hurt you. It can only help you. So anyway, looking at what we have up here. What's that? Yeah, the test on Thursday is paper pencil. It'll be in class. Yep, and there'll be a quiz online Thursday that's optional. But you don't have to do that one. If you're wiped out after taking the test. There will be, again, another like 40 or 45 minute lecture after the test is complete on Thursday. Just so you're aware. Okay. So the problems I have up here to give us a shot. Now remember, there are two different procedures here basically. Addition and subtraction, where we must have the same name to combine them. And then we combine counts and keep that same name. And then we have multiplication and division, where we do not have to have the same name. We are simply going to combine counts and then also combine the names. So for 1 and 2 here, we are adding and subtracting. So for both of those, we must have the same name or common denominator. So for number 1 here, we have 6 and we have 8. Our common denominator is going to be 24. What's this going to become? 15. Very good. 8 times 3 to make 24. So we have to do 5 times 3, which will give us 15. What's this going to become? 20. Great. 6 times 4 to make 24, so you have to do 5 times 4, which will be 20. Now we have the same name, which is the 24. So we'll combine the counts. 15 and 20 make 35. And we'll keep the same name of 24. Are we done? No. That's an improper fraction. Now again, my math lab might ask you to leave it as an improper fraction, which is fine. Or if you want to break that down into a mixed number, 24 can come out of 35 once with how many pieces left over? 11. How many of you had 1 and 11 24ths for that one? Good. For those of you that haven't done so yet, is there anybody that does not know how to enter that in a calculator to double check it? Is there anybody that needs me to go over that again? Yeah? Okay. So if you're going to go to enter that in the calculator, what you would do, 5/8 and 5/6. It would look something like this. You have an ABC key. On your calculator, it's down on the left side. It's the second or third key from the bottom on the left side. So you would enter 5/8. You would put in 5, ABC, and then 8. Plus, and then 5/6 would be 5, that ABC key, and then 6. And then hit equals. And it should spit out something like this. That means a 1 and 11 24ths is what that means on your calculator. You get to work? Okay. So back up to number 2. 2/3 minus 1/4. What do we have to do first? Common denominator. Good. What's that common denominator going to be? It will be 12. What's this going to be? 8. Good. 3 times 4, so 2 times 4 to make 8. What's this going to be? 3. Good. 4 times 3 makes 12, so 1 times 3 is 3. Now, of course, we have to remember that we are subtracting. 8 minus 3 makes 5. Over 12. We keep the same name. Good. For number 3, we are multiplying. When we multiply, do we need to find a common denominator? No. Multiplying and dividing, we do not need a common denominator. We can, if we want to, do something before we multiply, which is that cross canceling, right? We could just multiply this out. 2 times 9 is 18, 3 times 10 is 30, and then reduce it from there. Or we can look at this. What could we cancel? 2 and 10 can both be divided by 2, right? 2 divided by 2 is 1. 10 divided by 2 is 5. It's kind of like reducing a fraction, only you're doing it diagonally instead of straight above each other. Is there anything else we can reduce? 3 and 9 can both be divided by 3. 3 divided by 3 is 1. 9 divided by 3? 3. And now what's left is pretty simple. You multiply the counts, so the numerators. 1 times 3 is 3. And you multiply the names or denominators. 1 times 5 is 5. That is 3/5. That would enter into your calculator exactly the same way as that first one. 2ABC3 times 9ABC10. Number 4, what do we have to remember to do when we are dividing fractions? Invert or take reciprocal and multiply. What happens to the 3/4? It stays the same. The first number is the one being acted upon, so it does not change. So we change division to multiplication, and then 10 over 3. Now that it's multiplication, just like we did here, we can cross cancel. We can reduce before we do our multiplication. We see the 3's, which can both be divided by 3, will give me 1 and 1. Is there anything else? Yeah, 4 and 10 can both be divided by, by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. So 1 times 5 is 5. 2 times 1 is 2. 5 divided by 2 is 2 1/2. So reducing that down into a mixed number. Anybody have all 4 correct so far? Okay, any questions on those first 4? Okay. Well, these next 2 are kind of a bridge into our new material. I put them out there just to see. If you didn't get them, that's okay. I wasn't expecting it quite yet.
You mean the ones on our homework?
Yeah, there were a couple on your homework.
Yeah. But it's kind of got skipped.
So anyway, for number 5, we have those variables in there. How do we deal with that? Well, let's get my stray marks here. What I do when I'm dealing with these is I separate out the numbers. Just like when we were reducing these fractions with variables in them, I separate out the numbers. So I'm going to take my 2/5 times my 3/8. Is there anything I can... Now remember, the one thing we cannot do when the variables are in here is we cannot turn it into a mixed number. So no matter what, we're going to leave it as a fraction, whether it's improper or otherwise. But we can cross cancel. What can we cross cancel here?
2 and 8.
The 2 and the 8 can both be divided by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So now we'll go ahead and multiply. 1 times 3 is 3. 5 times 4 is 20. So the numerical portion of this answer is 3 over 20. Now we're going to look at the variables. I have, use a different color here. Come on. I have x squared over y here. Here I have y to the 4th over x. Now what I'm going to do is I'm just going to combine those. X squared, y to the 4th. And then I've got yx. I'm going to put them in alphabetical order so it's xy like that. And the process now is just like reducing a fraction. Well, we are basically just reducing a fraction. So for the x, our first thing we need to decide, is it going to be on top or bottom? How do we know it's going to be on top? Larger power. This is x to the 2nd, this is x to the 1st. Larger power is on top, x is on top. What power is it going to be? Just x. We find that we figure that out by subtracting the powers. 2 minus 1 is 1. So it's x to the 1 or just x. How about the y, top or bottom? It's also going on top because we have a 4 and a 1, and the 4 is bigger. What's its power going to be? 3, because it's 4 minus 1 makes 3. So the result of that problem is 3xy to the 3rd over 20. Whenever there's variables in your fraction, you cannot turn it into a mixed number. Because you don't know what the value of those variables is. So you don't know whether the top is bigger than the bottom or not. Okay, so over here then, I'm going to rewrite this. 6yx squared over 11. Divided by 8y to the 3rd over 5x. My first step in doing this problem has to be to get rid of the division, just like any other division with fractions. So the 6yx squared over 11 doesn't change. It's going to become times what? Perfect. 5x over 8y to the 3rd. We just flip this one over. Take its reciprocal. Now, just like before, I'm going to separate the numbers and work with them separately. So what numbers are going to go in here? What goes on top of this one? 6 over 11. That's just the numbers from the first fraction. What goes here? 5 over 8 of the numbers from the second fraction. So I've just taken the numerical portion from each. Let's get out of there. And now I'm going to treat those just like I would any other fraction multiplication. Can I cross cancel anything? Yeah, 6 and 8 can both be divided by 2. This is going to give me what here? 3 and 4. Can I reduce anything else with the numbers? No. So I have 3 times 5 is 15, and 11 times 4 is 44. So I know right now that the numerical portion of my answer is 15 over 44. So now I look at the variables. So I'm going to take out the variables. So this first one, what goes on top? Y x squared. What goes on bottom? Nothing. Good. Second one, what goes on top? X, and on bottom is y to the 3rd. All I'm doing is taking out the variables from each other. So now I'm going to combine. Here, I do have an x squared and an x that I'm going to combine to get what? X to the third. Perfect. That's like a 1. So it is x squared times x is x to the third. Then I have the y, and on bottom I have y to the third. Bless you. So in my answer, where's x going to go? On top, what power? To the third. There's nothing else to combine with the x to the third. So it just stays where it is and its power stays the same. Bless you again. Where does the y go? On bottom, because the larger power is on bottom. Remember, this is a 1, so the 3 is bigger. And what's the power going to be on the y? 2, because we subtract. 3 minus 1 makes 2. So that becomes 15x to the third over 44y squared. Questions? Obviously, I'm not done with examples, so don't worry, we'll do a few more. Or quite a few more, one of the two. So, let's take a look at some others. Let's try what operation is this? It's multiplication. All those parentheses are is another way of expressing multiplication. There's nothing to do inside either of them. It's just a one way of separating the numbers so you can isolate each number. So, to do this multiplication, what should be the first thing I do? Separate out the numbers. So what goes in this first one? 3 over 16 times 8 over 9. Good. Tell me what to do next. Okay. 3 and 9 become 1 and 3. Okay. 16 and 8 become 1 and 2. Any questions so far? Okay, what's next? 1 times 1 is 1. 2 times 3 is 6. So up here, my numerical portion is 1 over 6. Now, I might not need that 1 there. I'm putting it in there for now, but I might not need it if there are variables there. It doesn't hurt to leave it there. It doesn't change anything. So I've got 1 over 6 as my numerical portion. What's next? My variables, okay? What's going to go in this first fraction? Y over nothing. Second fraction. X squared over y squared. Good. When I combine those, what do I get? On top, it'll just be x squared y. Just putting them in alphabetical order. There's nothing with the same variable, so nothing to combine. On bottom, of course, it's just y squared. So then what do I have to do? Okay. So there's nothing to combine with the x squared, so the x squared just stays on top. Good. And then? Okay, yeah, for the y's, this is y to the 1, so the bigger power is on bottom. And the difference between 2 and 1 is 1, so it's y to the 1 or just y. So it's 1x squared over 6y, or it could be just listed as x squared over 6y. Either one of those would be correct. Questions? I'm sensing time to try one. Oh, why not? Oh, yeah? It was better last night than it is now? Uh-oh.
Say that I did last night.
I'll try not to muddy the waters too much for you.
I don't know if it's just because I'm using my calculator to go through it.
It's possible.
It's just the variables that are not
The numbers. If you, and that's one thing.
the letters that are screwing up.
Oh, sure. And that is one thing you can do is you can do, when you separate out the numbers, you can do that on your calculator. You just have to be careful because your calculator will tend to try to put it into a mixed number if it can, and you just got to make sure you convert it into it, keep it as an improper fraction. So. Try that one in your notes. Talk me through it.
5/8 times 4/15.
Okay, 5/8 times 4/15. Simplify it. So this will become 1 and 3, and this will become, okay? So 1 and 2. Then what? 1 over 6. And then? Okay, Z3 over P. Nothing over just Z, right? And then Z to the third over PZ, okay? And then? Okay, Z to the second is on top. And P's on bottom. So it could be 1 Z to the second over 6P or just Z to the second over 6P, either one. What do you think? Better than a sharp stick in the eye? These really aren't horrible. They're not. I mean, we're not talking like, you know, splinters under the fingernails type bad yet. The key with the variables, really, rather than writing it like this, you could just put them all together and just say, okay, I've got Z to the third, I've got PZ, and just put them together and combine them that way too works. I just like to keep it this way because I don't like skipping steps. Because all I did is I picked out, here's the variables that are on top, that's just Z to the third, and on bottom I just have P and Z. So let's say I have x to the fifth over 8y divided by yeah, what the heck, let's do it. 16x squared over 5y squared. What is the first thing I have to do here? Well, before I do it, yeah, I have to take the reciprocal. I have to change this into multiplication first. So yeah, I have to rewrite this as a multiplication problem. So the x to the fifth over 8y does not change. This first one stays exactly like it is. Now my division becomes multiplication, and the second fraction just gets flipped over. What goes on top? 5y squared, so whatever was on the bottom here, and on bottom, 16x squared, whatever was on top over here. And now this problem is exactly like the ones we were just doing. When I go to pull out my numbers, what's the first fraction going to be? No, there is no number on top, is there? What number is really there? It's a 1. That's 1x to the 5th over 8. Y. So it's really a 1/8. Remember, whenever we have like an x or a y, it's just like an inch. Instead of saying 1 inch, we just say an inch. Same thing. X or y is really 1x or 1y. So that's 1 over 8 times 5 over 16. Can I reduce anything? No. So 1 times 5 is 5. 8 times 16 is 128. So my numerical portion here is 5 over 128. And then take our variables out. Good. What's going to come down here? Well, what are the variables in this first fraction? X to the 5th over y. Bless you again. How about my second fraction? Y to the 2nd over x to the 2nd. And now we're just going to go ahead and combine them. Just basically moving straight across here. X to the 5th y squared. I'm just putting them together in one fraction. Just make that look like a 2. Just squishing them together all in one. And then this is yx squared. I'm going to put them in alphabetical order. So x squared y. So what's that? Okay. Yeah, so the y and x squared, we're just going to push them together, and I just put the x first because it's easier to have them in alphabetical order. Okay, gotcha. So now, x is going to go on top with a power of 3. 5 minus 2 is 3. Y is going to go on top with a power of 1, or no power, right? This is a 2 and a 1. 2 minus 1 is 1, so you can put it as just y. So 5x to the 3rd y over 128. Any questions? I'm going to have you guys try one. Try that one in your notes. Where do we start with this? We have to change it to multiplication before we do anything else. So the 10m over 11p squared does not change at all. Times what? 22p over 5 m to the 3rd. And then ten over 11 times 22 over 5. Good. We're just taking out the numbers. And then simplify. 5 and 10. 2 and 1. Take out the 11 here, so we got 1 and 2. So what do we get? 2 times 2 is 4. 1 times 1 is 1. So 4 over 1. So we got 4 on top, 1 on bottom. Then what? Take out your variables. What's it going to be? M over p squared. P over m to the 3rd. Good. Now we just combine those. mp over m to the 3rd p squared. And then Where's the m go? M goes on bottom, because the bigger power is on bottom, m to the third. And then we subtract. 3 minus 1 is 2. Where's the p going to go? On the bottom, because this is p to the 1. 2 is larger, so p goes on bottom. And it has a power of 1 or just p. So 4 over 1m squared p, or it could be written as 4 over m squared p without the 1. Any of you get that? Couple? Okay. One little advice I'll give you is when you flip this over to make it multiplication to here, cover up the original problem completely so you don't look back at it when you go to fish out. That's one of the big mistakes I see is when you go to fish out your variables, you go back to the original problem instead of this one. How do you guys feel about these? Didn't like that one? Okay. You guys want to try one more of those? Why not? What's it going to hurt? Try this one in your notes. See what you come up with. Tell me where to start. Three over 16 b4 times 8b squared over 9d squared. Okay, now I'm going to put that original problem off screen so I don't look back at it. That original problem no longer exists. This is what we are working with now. So then what's next? Okay, so I'm going to pull out the numbers. 3 over, not 8, 3 over what? 16 times 8 over 9. We've already flipped it. Right? So then, simplify. 2 and 1, 1 or 2, yep. Which becomes 1 over 6. So in our answer, 1 over 6 is the numbers. And then blank over b4. No variable here, b to the 4th on bottom. Over here, actually the b squared goes on top and b squared on bottom. That's why we cover up the original problem so we don't look back at it. That no longer exists. We're dealing with this part now after it's been flipped. So now on top we just have the b squared. On bottom I just have to make sure these are in order, so it'll be b to the 4th d squared. So in my answer, b will be on bottom because that's the larger power is the 4. It'll have a power of 2. Good. Squared 4 minus 2 is 2. And there's nothing to combine with d squared. So that is it. 1 over 6b squared d squared. We looked at something like this last time as well. I just want to review it quick since we're dealing with the variables in our fractions. What would we do with it? Well, first thing we do is this. We separate it. When we have a fraction raised to a power, we separate it. So it's the numerator, which is the 3a to the 5th to the power of 4, over the denominator, which will be 2bc to the 3rd to the power of 4. So we can separate it so that the numerator is to that power and the denominator is to that power. Then what? Yeah, we do the numbers first. Now the number actually does get raised to that power. 3 to the 4th is 3 times 3 times 3 times 3, or 81. On your calculator, just put 3 and then that caret key and 4. Or 3 if you have the x to the y key and then 4. Gives you 81. So on yours, you do the x to the y key. So type in 3, and your x to the y key is like up here. I think it's right on the edge here. It's the second one from the top, I believe. 3x to the y 4 gives you 81. But then we have to do the variables. We have a to the 5th to the power of 4. Now if you have a variable with a power and you're raising it to another power, what happens to the powers? They're multiplied. If you're multiplying the variables, you add the powers. But if you're taking a power of a power, you multiply them. So it's 5 times 4 is 20. Remember what that is, a to the 5th to the 4th power. That is a to the 5th times a to the 5th times a to the 5th times a to the 5th. 5, 5, 5, and 5 makes 20. So a to the 20th. Any questions so far? Okay. On bottom now, we've got 2bc to the 3rd, all to the 4th power. What happens to the 2? Well, 2 to the 4th power, yeah. 2 times 2 times 2 times 2 is 16. Yep, think of this as 1, so 1 times 4 is 4, so b to the 4th. C to the 12th, good. 3 times 4 is 12. Got her? Okay. We'll do another example or two of these before I let you try another one. Okay. Let's do something like this. So now remember, we can separate it out. We do the numerator. So 5mp to the 3rd power. What goes in the denominator? Four pt to the 4th, and in parentheses to the 3rd power. Now what? Start on top. What's the number going to be? 125. 5 to the 3rd power. 5 times 5 times 5 is 125. M to the 3rd power. This is m to the 1. It's 1 times 3 is 3. P to the 9th power. 3 times 3 makes 9. Any questions on where the top came from there? On bottom, what do we do? What's the number going to be? 64. Yeah. 4 to the 3rd power. 4 times 4 times 4 is 64. Now we think of this as p to the 1, so this is going to be p to the 3rd. 1 times 3 is 3. t to the 12th. Good. 4 times 3 makes 12. Are we done there? Not quite. Why not? There's p's on both top and bottom. So the 125 isn't going to change. The 64 isn't going to change. The m to the third isn't going to change. P comes next alphabetically. Is it going to go on top or bottom? Top, because the bigger power is on top, and it'll be a power of 6. 9 minus 3 makes 6. The t to the 12th is just going to stay where it is on bottom. Why didn't I write down the t to the 12th before? Because I wanted to make sure that didn't have to be a p in front of it. The p is alphabetically first. I wanted to. I mean, it wouldn't be wrong on a test if you didn't put it first, but that one's a little tricky. I probably wouldn't do that to you on a test where you had to reduce it at the end like that. Depends on whether you guys.
Be buying the alcohol.
Depends on how much you guys annoy me between now and Thursday. Right?
Or that they automatically percent.
Okay, let's do another one. I do really value my ability to walk out into the parking lot without having to stop at the door to listen for revving engines. So I probably won't do that to you. Give that one a shot in your notes. Okay, so looking at this one, our first step is to separate it. So it's just the numerator to the power of 4 and just the denominator to the power of 4. Because we have this fourth power here. On top, what are we going to get? Careful. That'd be 3 to the third would be 27. 3 to the fourth is 81. A to the 12th. Good. 3 times 4 makes 12. A to the 12th. Any questions where that 81 A to the 12th came from? Okay. On bottom, what's the number going to be? 256. 4 to the 4th is 256. B to the 8th. Good. 2 times 4 makes 8. And C to the 16th. 4 times 4 makes 16. How many of you had 81, A to the 12th, over 256, B to the 8th, C to the 16th? Everybody know how we got it? Any questions? What do you need? Okay.
It's not done with it. You combine the A's.
There's no other A's. That's it. This actually looks a lot like what I would do to you on the test, just so you know. Similar to that. Now, just as a little bit of a review, how would you handle something like this? Well, it's the same thing. It's just 2 to the 6th over 5 to the 6th. 2 to the 6th is 64. 5 to the power of 6, 15,625. Not so bad? Here's where we step it up just a touch in difficulty. I showed you an example of this at the end of class yesterday, so you knew it was coming. Something like this. Now, if I'm adding these, first thing I'm going to do is I'm going to set them up vertically just because that's how I think when I add. But I do need to find a common denominator. Remember, a common denominator is least common multiple. And I'm finding the least common multiple of what two numbers? Well, 2x squared and 4x, right? Now for 2 and 4, what is the number that it's going to be? 4, right? Just the 4. When we're dealing with a least common multiple, what do we do for the variables? It's either going to be the largest power or the smallest power. Least common multiple, remember we have our numbers, it's going to be bigger than the numbers, right? Bigger than or equal to. Least common multiple, it'll be the largest power of the variable. So the largest power of the variable here is 2x squared. So our common denominator, or least common denominator, is the least common multiple of those two denominators, which will be 4x squared. So for this first one, do I need to do anything to the number? Yeah, I have to change. Perfect. 2 times 2 to make 4. So I'm going to have to multiply the top times 2. Do I have to do anything to the variable? No, I have an x squared and I'm keeping it as x squared. So nothing to the variable. So 5 times 2 is 10. Good. This bottom fraction, do I have to do anything to the number? No, it's already a 4. Do I have to do anything to the variable? Yes, I have to turn x into an x squared, so I multiply by x, right? It's multiplied by x to turn x into x squared. So I multiply the top by x. 3 times x is 3x. Now I have the same name. I have a common denominator. So my answer, I'm going to keep that same name. It's going to be over 4x squared. The tricky part here is what's the numerator going to be? What's 10 plus 3x? It is 10 plus 3x. Can't combine it any further. So it just looks like that. 10 plus 3x over 4x squared. Any questions? No, the calculator is not much help at all on that one. So here, you guys talk me through what I need to do here. I'll write it out vertically. I'll start you out with that. Common denominator, good. So I have 3x and 6x. For the numbers, what's that common denominator going to be? 6. And the variable? Just x. They both have an x. The highest power is just the 1, or just x. So I'm going to have a 6x here and a 6x here. That's my common denominator. What do I have to do to the 3x? Well, to turn a 3 into a 6, I multiply by 2. Do I have to do anything to the variable? No. So I'm just going to multiply the top by 2. 7 times 2 is 14. Okay, on bottom, what do I have to do? Nothing. 6x is already 6x. So the 5 will not change. That's just going to stay a 5. Then what? Well, my answer, I have the common denominator of 6x, so my answer is going to have a denominator of 6x. What do I do with my numerators? Yeah, 14 plus 5 is 19, so it's 19 over 6x. Do I change that to 3 and 1? No. When I have variables in my fractions, I never, ever change them into mixed numbers. It always stays as improper like this. Again, that x could be a 7, so this isn't an improper fraction. We don't know if it's improper or not, so we can't change it. So it'll always stay like that. Any questions? Yeah, this would be just like if I was changing 7 over 3 and I was changing it to a denominator of 6. You got to multiply by 2. Throwing those variables in there makes the fractions look a whole lot more. Okay. Let's have you guys try one on your own here. Try that one on your own. What do we get for a common denominator? 9m squared. Good. I'm going to stop there. Any questions on where the 9m squared came from? The 9 is just the least common denominator between 3 and 9. And then for the variable, you take the highest power of the two. So m squared. Bless you. So m squared is the higher power. Do we have to do anything to the 3m squared? Yeah, it's got to change to 9m squared. So we have to change the number by multiplying by 3. Do we have to change the variable? Nope, it's already a square. So what do we have to do to the top? Times 3. 2 times 3 is 6. Good. Down here, do we have to change it at all? Yeah. Do we have to change the number? No. The variable? Yes. So we have to multiply by m to make m times m to be m squared. So what do we do to the top? Times m. 5 times m is 5m. So now in our answer, the denominator is 9m squared. That's going to stay the same. What's the numerator? 6 plus 5m. Or 5m plus 6, either way. Since those have different names, this is 1's and this is m's, we cannot combine them any further than that. Let's try another one. Try that one in your notes. See what you come up with. Common denominator. 10d. Very good. Do I have to do anything to this one? Times 2. So this will be times 2 to make 4. Do I have to do anything to this one? No. So this is just the 3. And then 4 plus 3 is 7 over 10d. That one's not so bad, right? The one I asked you on the test will be very similar to that one, just so you know. Even I have a nice streak in me sometimes. Apparently I developed a conscience somewhere along the line.
You been doing it too long?
No. Maybe fear, I don't know. Not really. Oh well, long story. So 2 over 5x squared minus 3 over 10x. So now the big difference here is this is subtraction. How does that change things? Really not at all. So we have 2 over 5x squared, 3 over 10x. We still need to find a common denominator. That common denominator is going to be, remember, yeah, between 5 and 10, it's a 10. And for the x squared and x, the largest power is the squared, so x to the second. So I'm going to stop. Anybody not know or have questions about where the 10x squared came from? The largest power of the variable, which would be the x squared. Then for the 5 and the 10, I'm just, you got to figure out what that one is. I've been doing them so far so it's easy, so one of them's a multiple of the other. But you could have like 4 and 6, so you'd change them into a 12 or whatever. So it's not always the largest number, but for the variable, it is always just the largest power. I'll do the next example. Yeah. Okay. So for this top one, what do I have to change? Yeah, so 5 times 2 to make 10. Do I have to change the x? No. So what do I do on top? Times 2 makes 4. On bottom, what do I have to change? Do I have to change the 10? Nope. I have to change the x into an x squared by multiplying by an x. So 3 times x is 3x. I'm going to pause there. Any questions on how I did that renaming to change the denominators? Okay, so now my answer. We have the common denominator of 10x squared. So my answer has a denominator of 10x squared. What's my numerator? 4 minus 3x. Questions? Okay. Let's look at another one. So again here, same type of deal. Common denominator. First of all, with the numbers between 6 and 4, it's going to be what? 24 would work, but 12 is smaller. And then for the variable, x squared. Questions on the 12x squared, where that came from? What do we have to do to this one? Do we have to change the number? Yeah, 6 becomes 12 by multiplying by 2. Do we have to change the variable? Yes, so we have to multiply by x to turn x into x squared. What do we do to the 5? Times 2x. So 5 times 2x is 10x. On bottom, do we have to do anything to the 4? Yes, times 3 to make 12. Do we have to do anything to the x squared? No. So what do we multiply the 3 by? 3. 3 times 3 makes 9. And then 10x minus 9 over the 12x squared. Very good. So 10x minus 9 is just 10x minus 9. And then our common denominator is 12x squared. How you feeling? Better? I'll have you guys try one and then we'll take our break. Try this one in your notes. Okay, so common denominator will be 12. Good. What do I have to do to the 6? Times 2. So 5p times 2 is 10p. Good. What do I have to do to the 4? Times 3. So 3p times 3 is 9p. So then what? 10p minus 9p is 1p, or just p if you wanted to do that, over 12. So 1p over 12 or just p over 12, either one is fine. Okay, let's take our break. It is 10:15. Let's start up at 10:25.